Hello, Mr. Harry, are you alright?
Yes.
Okay, so we talk about the golden ratio, yeah? Golden ratio. And it's represented by a Greek letter, which is like that, yeah? 5.
It looks
5.
like a D.
Yeah, 5. Okay, 5. Something like that, yeah, 5.
Ah.
So it's defined as, look, if we have a length segment and the bigger one is A, the smaller one is B, right? And the sum is A plus B. The ratio between the sum to the bigger one is equals to the bigger one divided by the smaller one, right? Right? This is golden ratio. If we set B equals 1, then A is the golden ratio, okay? So let's try to solve this. Then we can multiply this, yeah? So A squared, yeah, A squared equals A plus B times B, right? And this is what? AB plus B squared, right? Because we said B equals 1, so A squared equals A plus 1, right? If we move these two to the other side, so what? A squared minus A minus 1 equals 0. Quadratic function. We know, yeah, there are two roots, right? Two roots for each quadratic function equation. And look, so the quadratic function is what? If for ax squared plus bx plus c equals 0, we have two roots, which is 2 times a minus b plus minus b squared minus 4ac. Okay? Yeah? Okay, so look, if we substitute, look, this a is 1, right? This a is 1, so that's 2 times minus b, which is 1, plus minus b squared, which is 1, minus 4, negative 4, which is 5. Right? And then because we want the positive, yeah, positive the value, so we can just plug in these values. That will be, this is the golden ratio, which is approximately this one, this value, yeah, 1.618. Yeah, let's put this one. So last time we talked about Fibonacci number, yeah. The first two numbers 0, 1, and the next few numbers is what? Is the sum of the previous two terms. Alright? 35, 56, 91, and what's that? 147, okay? And then we add one more, which is 238. Okay? So look, if this one is B, this is A, and this is what? B plus A. Right? If this is B, this is A, this is B plus A, right? So because this Fibonacci number goes infinity, right? So when this goes forever, the ratio between two terms, consecutive two terms, right, is A divided by B will be what? A plus B divided by A. Okay, look, what's that? Golden ratio, yeah? We just defined it there. So let's just try a few terms, okay? Let's try to calculate this number. Okay, and then this number. Okay, I'm going to use the calculator, okay? I'm using the calculator. 147 divided by 91 is 1.615, okay? 1.615, and then this one, 238 divided by 147 is 1.618. Okay, it's very close to 1.618, right? Remember, this golden ratio is 1.618, blah, blah, blah. It's an irrational number, yeah, irrational number. Irrational number. A irrational number is a fraction that cannot be represented by p divided by q, where p and q are integer, right? Like the square root of 2 pi. These are all irrational number, but like 20 divided by 3, this is a rational number, right? Because these two are integer. So we can introduce another mathematics way to write the limit, to calculate the number which has infinity, right? Look, we can do this limit when n approach. How do you write the infinity?
Write down 8.
Write down a. Okay, write down a. Yeah. By the way, the Facebook, Facebook changed the logo to Meta. Facebook, they changed the logo to this. Facebook. So look, we can say fn plus 1 divided by fn. Right, because this is Fibonacci number. The next term, n plus 1 a Fibonacci number divided by its previous term, this will be equals to 5, and which is approximately 1.618. Okay? Yeah? Make sense? Okay, then we also talk about different ways of calculating the Fibonacci number, right? At least you know two, right? One is using the recursion. Okay? If n equals 0, return 1, return 0. If n equals 1, return 1. Else return fn minus 1 plus fn minus 2, right? And we are using the cache function to avoid repeating calculating the intermediate numbers. And we can also use using iterative number, right? For I, we can just for I in range n, a b equals b, a plus b. Okay. So this golden ratio we just talked about, because look, is x squared minus, is basically the root of x squared minus x plus minus 1 equals 0. Okay, it's the least. And how about if I say if I put a 2 here? Okay, so we're going to introduce a new sequence which is called the golden, golden. And what's next to golden? The matter, the matter, yeah. Matter, what's matter? Yeah, well done. Golden, silver. So today, silver ratio. So matter, yeah? And golden, silver, what's next?
Bronze.
Bronze or copper, yeah? Sometimes copper, you know the copper? Yeah? Okay, so that's silver. Silver, so when this is 2. And copper or bronze when this is 3. So look, x squared minus nx minus 1 equals 0. This is called matter ratio equation. Matter ratio equation. So when n equals 1, then the root will be golden. When n is 2, that will be silver. When n equals 3, I don't know, copper or bronze, okay? Yeah? Yeah, we already start a lot, right? With golden, this is Fibonacci number. Yeah, so look, it's very beautiful, right? Because Fibonacci number contains the golden ratio, right? Make sense? How about this is silver? If we have these two, so look, x squared minus 2x minus 1. So what's the root of it? 2 times a, which is 1, to 2 minus b, which is what? Okay, maybe we can just solve this. Look, if x squared minus nx minus 1 equals 0, what's the root? What's the root? 2 times a, what's a? What's a here?
That is
1, right?
1.
2 times a minus b, which is n, right? Plus minus
1.
b squared is n squared. Yeah? Minus 4 times a, so plus 4, right? Right? This is a. So basically for this equation, a is 1, b is minus n, c is minus 1, okay? And we can just substitute, remember the formula. 2 times a minus b plus minus b squared minus 4ac, okay? This is very important to the quadratic equation, right? There are 2 roots. What's this? This is the root, 2 roots to this equation. Yeah? Quadratic equation. A, B, C are constant, and we want to find the value of x. And this is the formula. Yeah, there are 2 roots. Okay? Make sense? Huh? Okay, so this. Okay, so look, we're coming back to this. So when n is 1, so it's when n is 1 is 1 plus 5, right? This is golden ratio already. Then when n is 2, 2 times 2 fraction 2 over 2 plus equal minus 2 square 4 plus 4 8, yeah, 4 plus 4. Okay, so we can substitute, we can do this a little bit. So 2 plus minus 4 2, right? 4 times 2 divided by 2. So that's 1 plus minus, what's it? Well, if I take this 4 outside, that would be 2, right? Yeah? So I cancel out, right? Cancel out this 2, so it will be like that. Okay, if then we keep the positive one, because this one is bigger than 1, so we keep the positive one. So zero ratio is this one.
1 plus 2 square.
2 squared. So squared. So what's this value? We don't know yet, yeah? What's
1 point something.
1 point something? Do you still remember how?
1.33, I think.
So okay, first of all, how do we estimate this square root of 2? What's this value? How do we estimate it? Remember, how do we estimate it? How do we estimate it? There are a few ways we can estimate it. So look, the integer bar is between 1 to 2, right? Right? Yeah?
Yeah.
Because 1 square is 1, 2 square is 4, right? Alright? So is it so this square is 2, right? So it's less than 2, am I right? Yeah? Do you get it? So look, let's assume it's 1. Yeah, because the integer part is 1. So 1 plus something, the fraction number x square equals 2, right? Am I right? This is 1 point x, this is square root of 2, right? If I square it. Okay? So this becomes 2 on the right hand side, right? X is a number. X is number between 0 to 1, right? It's a fraction number. It's like 0.5, 0.2, right? So look, remember, a plus b square, what's this? How do we unroll this? This is a square plus b square plus what? Do you still remember? 2 times a times b, yeah. Okay, so but look, this one, because x is so small, yeah, it's a small number, So let's just do this, look. Then this is 1 square plus s square plus 2 times 1 times x, right? 2x equals 2. Okay, look, x is a number between smaller than 1, alright? So let's just don't consider it at the moment. So look, 1 plus 2x equals 2. What's x? 1 plus 2x equals 2. So 2x equals, I move this to, so x equals what?
0.5.
Oh, 0.5. Okay, so now we have a good estimation, 0.5. Okay, so x is 0.5.
I think it's something like 0.53.
Okay, look, now at least now 1.5, right? Because look, 1.5 square is 2.25. It's not 2, right? So we can keep doing this. Look, 1.5 plus x.
I think
Yeah?
it's 1.33.
Look, no, 1.5x. Let's do it. Square equals 2. And then we can keep doing this. Look, 2.25 plus x squared plus 2 times a x, that will be 3x equals 2, right? Alright? So we abandon this for a moment because it's too small. Okay. So 3 times x equals minus 0.25. So x is what? X is what? Minus 1 over 12, right? This is a quarter divided by 3 is 12. Okay, so look, we have this is x. Basically, x is the adjustment term. Okay, so we keep amending the result. So the previously is 1.5, right? And then I can just minus what? 1 over 12. So what's this number? 1 over 12. 1 over 12 is 0.083. Okay, if we use 1.5 to subtract that, it will be what? 1.417, yeah? Alright? So look, this number, if we square this number, what happened? 1.417 times 1.417 is 2.007889. You see? Very close, right? So we can keep doing this. Look, we already know this number, and then we can plus x and then square equals 2. And then we can keep doing this by abandoning the x squared because it's so small, right? And then we can solve this linear equation and get the x term. That's adjustment and put it back. Do you get it? This is the way to estimate it properly. Make sense?
Yeah.
Okay. So, okay, where are we? Where are we? We talked about a lot and we forgot the original topic. So, yeah, this is the C variation. Right, C variation. So how is that useful, right? How is that useful? Remember, so look, the first few terms, the first two terms, yeah? B, A, okay? How about if I say the next term is what? 2 times A plus B, yeah? Remember, wait, the Fibonacci number is what? Fibonacci number, let's say Fibonacci number. We can do this. If the first one 0, if n equals 0, is 1, if n equals 1, and then what? If n is bigger than 2, is FIB n minus 1 plus FIB n minus 2, right? Yeah? Equation, yeah? Right? How about if I say, okay, if I times n here, if I times 2 here? Look, 2. So look, if I have a function that fn equals what? And I can say 2 times fn minus 1 plus fn minus 2 if n bigger or equal than 2. Okay? So what's this? Look, alright. What's the difference between this one and the Fibonacci number? Look at this. There's only one difference here, which is what?
If n bigger or equal than 2.
So what's the difference? How is the difference between this one and then Fibonacci number?
Because in Fibonacci number it's
There's no 2, right?
Yeah.
I put the 2. So okay. So let's write this. So look, okay? 0, 1. Okay, so what's next term? What's the next term?
1.
No, not the Fibonacci number, the one that times 2. 2 times
2.
2. Okay, and what's the next one?
6.
Huh? 2 times this plus 1.
2 times
2 plus 1.
5.
What's the next one? 2 times this
27.
plus 1. 2 times this.
27.
Huh?
27.
How is that 27?
I don't get how do you work it out.
Look, fn equals 2 times fn minus 1 plus fn minus 2. Okay? You said this is the difference between Fibonacci numbers without these 2. Now I have these 2. So the next one is 2 times 5 plus 2. 12. 2 times 12 plus 5.
29.
2 times this plus this.
70.
70, okay? This keep going, right? Yeah, you see this?
169.
Yeah, 169. Okay, and keep going. Okay, so we call this. Remember, this is the name. We call it pair number. Pair number. Pair numbers. Okay, this is the term for the pair numbers. So each one is the 2 times the previous one plus the one before. Right? This is called pair numbers. Yeah. So we can also use it. It's quite similar to the Fibonacci number. We can just do this. Define pair n. Okay. And if n equal 0, return 0. If n equal 1, return 1. Else return what? Return 2 times pair n minus 1 plus pair n minus 2. Okay. And what's the one we're missing? hash, right? Because we don't want to,
Cash.
yeah. Okay, so an iterative method, okay, iterating number, define pair, and we can say, okay, A, B equals 0, 1, and then 4 in range, and we can say 2, A, B equals what? A will become the new B, right? And then B will become the 2 times B plus A, right? 2 times the previous one plus A, right? Okay, let's work B and A, okay? So make it better, B and A. So B will become the new A, right? And then that will be 2 times A plus B. Okay, and then we can just return B, okay? Whatever. This is the pair number. Okay, so C variation is related to pair number, and golden ratio is related to Fibonacci number, okay? Just to make it clear. So why is it useful? How do we use the C ratio? Remember that the C ratio is 1 plus square root of 2, right? If we're not sure what's the value of these, we can calculate the pair number. The one stupid way would be to calculate these. Remember, right? 0, 1, 0, 1. What? 2 times this plus 2, 5, 12, 24, 70, 116.
It's not 24.
29, 29, and then 70, okay, and then this keep going on, right? Because what? Because look, this is B, this is A, this is 2 times A plus B, right? So the C ratio will be 2 times A plus B divided by what? Divided by A equals A divided by B. If we set the B equals 1, right? If B set it to 1, then this is C ratio, and we use this Greek letter, which is what? Delta. I don't know how to write the delta. Delta S to represent the C ratio. Okay, B equals 1, then we can say 2A plus 1 times 1 equals A squared. A squared minus 2A minus 1 equals 0. Remember, you see? This we just changing from the golden ratio where this is 1 to 2. Right? So let's solve this equation. Look, let's solve this. So 2A minus B. Look, it's the same. 2A minus B plus minus square root of A, right? Okay, so this is 1 plus minus square root of 2. Okay, so that's where we could get this C ratio is where the C ratio from. Okay. Okay, look, let's write. Look, Eric, look. Remember the continual fraction. A plus B divided by A equals A divided by B, right? Look this. Then we can unroll this. Look, that will become what? 1 plus B divided by A equals A divided by B. Right? This is the golden ratio, which is 5, right? 5. Yeah. A divided by B equals golden ratio, and what's the B divided by A? What's B divided by A?
A.
Is the golden ratio 1 over golden ratio, yeah? So we can say 1 plus 1 over golden ratio equals golden ratio, right? Yeah? Alright, this is how we get it from here. And the same as, look, 2A plus B, the C ratio, right? And then it will be 2 times 2 plus what? 2 plus B divided by A equals A divided by B. This is delta S, delta S. I don't know how to write it. Delta S. So look, this is delta S, this is 1 over delta S. So 2 plus 1 over delta S equals delta S. Okay, so this is the C ratio. Okay, so look, let's take this golden ratio, for example, right? So this golden ratio equals this one. Okay, how about if I replace this with the definition of golden ratio? Look, so it'll be 1 plus 1 over, this golden ratio is this, yeah, recursion, yeah, so it's 1 plus 1 over this, right? Look, what just happened? Yeah? Does it make sense? Yeah? What did I just do?
You just put a golden ratio sign.
Okay, so I can keep doing this, yeah? So I can keep doing this, yeah? So 1 plus 1 plus 1 plus 1 plus. Yeah? This is the this is another way of writing the golden ratio. And similarly, we can do this with the which is the silver ratio. Okay, so let's say 2 plus 1 over, look, this is what? This is what? 2 plus this, yeah? 2 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus, right? Silver ratio. And as you can imagine, if we want to change this silver ratio to bronze, and we just change this number to n, to 3, yeah? 3. N. So this is continuation fraction. So if this, there's a way to do it, yeah? There's a way to write it. Look, if A0 plus 1 over A1 plus 1 over A2 plus 1 over A3 plus, and we can write it as a list. So A0, semicolon, A1, A2, A3, blah, 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 okay? So for golden ratio, the value is 1, 1, 1, 1. For the silver ratio is 2, 2, 2. And for the bronze is 3, 3. Okay? Make sense? So what's the silver ratio? 1 plus square root of 2, that's equals to 2.414, right? Something like that. And how about if this bronze will be what? Remember that equation, 2x squared minus nx minus 1 equals 0 when n is 3. Yeah? 2a minus 3 will be 3. Yeah? Come on, look at me. Plus b squared 9 minus 4 plus 4, right? So this is the bronze. Okay, so this is the value for the bronze ratio when n is 3. Okay, when n is 3, this is the rule. Remember this. Yeah, I keep talking about this. Yeah, this is very important equation. Okay, can you remember this?
I can't.
You can't. Okay, so can you write the quadratic equation? What's quadratic equation? Ax squared plus
B
x plus
C
equals 0. Okay.
and
Okay, so look, A, B, C are known, constant are the values. So we can plug in here, right? And this gives the solution. So the x equals this, 2, yeah, plus equals, so there are 2 to this equation. So quadratic equation, yeah, remember we talked about this. There are 2 roots. This is 1, this is 1, right? Make sense? Yeah? There are 2 roots. Quadratic equation, this or this, yeah? It could be something like that. When a is smaller than 0, it's pointing down. When a is bigger than 0, it's pointing up, okay? Make sense? Yeah? Okay, so to sum up, what have we learned today? Silver ratio, and then how can we estimate the silver ratio? How can we estimate the silver ratio? Remember the Pell number, right?
yes.
So look, the Pell number if it's p, so limit when n approximately to infinity. Look, Pn plus 1 divided by Pn, that would be silver ratio, which is delta. How do we write the delta? Delta S. Delta S, which is equals 1 plus square root of 2, right?
Yes.
And this is approximately 2.414. Right? We spend some time to estimate this value. Okay, and then to the Fibonacci number, the golden ratio, similarly, limit n approximately infinity. Yeah, when n approximately approach infinity, right? Fn plus 1 divided by Fn, the ratio between the consecutive two terms is equals to 5, right? And which is equals to what? Which is equals to what? Come on.
Which is equal to
What is equals to what? 0, 1, 1, 2, 3, 5. Which is what?
Fibonacci number.
Yeah, the next term divided by the previous term equals what? Is
The golden ratio.
golden ratio, which is this. Yeah? 1.618. Okay? Yeah? Two terms. And how about limit when n over approximately to infinity, right? And then we want to calculate this value. 1 over n. So what's this? Come on, think about it. Just simple example. When n goes very large, what's 1 over it? What's the value of it? 1 over it.
1.
Huh?
1 over infinity, really small.
Small, and which is what? If we really small, to close to what? When n goes to infinity, 1 over it, you say it's very small.
Yeah.
And what's the value? What's the value?
0.
0, yeah. Yeah, you see? A million, 1 over a million, very small, very close to 0. Okay, so that's what it means. When n goes infinity, this value becomes 0, right? But in fact, you can't find a value there's no such thing as infinity, right? So this math equation, lim stands for limit. Yeah? Okay, so let me think about any other things. So we talk about the pair number, yeah. Okay, so there's one last thing. Okay, you don't need to remember. Okay, so look, the pair number, the first two items is 0, 1, right? Okay, if we can change this to 2, 2, if the first two number is 2, 2, it's called pair Lucas number. Okay.
How Lucas number?
Okay, pair Lucas number. Just and the pair Lucas number is all except the first two numbers are different. The next term is always 2 times the previous term and plus the 1 before, right? It's the same. Okay, so this is another small thing. Okay. Okay, so that's it for today. Good job. Bye bye.
Bye.